All right, here's example 6 with reference angles. So this is one of our more complicated examples compared to the first 4 anyway. So find the reference angle for 17 pi over 6. So what's going to make this one more complicated? Well, let's first remember the first thing we want to ask ourselves is, okay, it's in radians, so is this between 0 and 2 pi radians? Well, remember 2 pi radians, okay, 2 pi, we want to get a common denominator here, so multiply by 6 over 6. So this is 12 pi over 6. So no, actually, 17 pi over 6 is not between 0 and 2 pi, because 17 pi over 6 is larger than 12 pi over 6. Okay, 12 pi over 6 is 2 pi. So 17 pi over 6 is outside of that little nice interval for us. So 17 pi over 6 is larger than 2 pi. So remember, a few videos ago we talked about what to do there briefly. And what we want to do is find the coterminal angle between 0 and 2 pi for this angle here. Okay, so what we do then is take 17 pi over 6. Okay, so our first step in this case, which is a new thing for our examples, haven't had to do this yet, 17 pi over 6 minus 2 pi. Okay, so figure out what that is. And again, multiply by 6 over 6 for the common denominator. So 17 pi over 6 minus 12 pi over 6 equals 5 pi over 6. Okay, okay, so 5 pi over 6 is coterminal with this guy. So since these two angles are coterminal, they're going to have the same reference angle. Why is that? Well, remember how we defined reference angles? Remember what the definition of a reference angle is? A reference angle is the acute angle between the x-axis and the terminal side of the given angle. So the reference angle is just the angle between the x-axis, the acute angle between the x-axis and the terminal side of this angle. Well, if this angle and this angle have the same terminal side, then naturally, by definition, they have to have the same reference angle, because the reference angle is defined in terms of the terminal side. Okay. Well, if these have the same terminal side, then they're going to have the same acute angle between that terminal side and the x-axis. Okay. So they're going to have the same reference angle. So in other words, coterminal angles have the same reference angle. So maybe that's worth writing down. Coterminal angles have equal reference angles. Okay, so coterminal angles have equal reference angles. So we'll put a big old fluffy cloud around that because that's kind of important. So coterminal angles have equal reference angles. So 17 pi over 6 is not between 0 and 2 pi, but 5 pi over 6 is, and 5 pi over 6 is coterminal with this guy. So all we have to do is find the reference angle for this guy. And since these two guys are coterminal, they have the same reference angle. So find the reference angle for this, then automatically we have the reference angle for this. Okay? And we'll draw a picture of all this too. So anyway, speaking of drawing pictures, that's our next step. Okay, now that we have a coterminal angle between 0 and 2 pi, we want to draw this guy here. So 5 pi over 6, notice that is a special angle on the unit circle, right? So we ought to know where that is. But if we don't, we can consult our unit circle. So x-axis, y-axis, we consult our unit circle. Pi over 6, 5 pi over 6 is up here in the second quadrant. So we do want to know that though, for sure. So 5 pi over 6 is up here. Okay. So here's 5 pi over 6. Okay. Now since we're between 0 and 2 pi and we're in the second quadrant, how do we get our reference angle? Well, remember the reference angle is the acute angle between the x-axis and the terminal side, which is going to be this angle right here. Okay, so the acute angle between the x-axis and the terminal side of the given angle. Well, not in this case, not really the given angle, but coterminal with the given angle. Okay, and we'll talk in more detail about that near the end of this example. So anyway, 5 pi over 6, this angle is what we want. How do we get it? Well, let's zoom in. If we go all the way around a half revolution, that's going to give us pi. If we subtract off what we don't want, that's pi minus 5 pi over 6. That'll leave us what we do want, or that'll leave us with what we do want. Okay? So take pi, okay, go around 1/2 revolution, okay, so we're all the way over here. That puts us all the way over here. Okay. Now subtract off 5 pi over 6, so then we'll just be left with this piece right here. Okay, so pi minus 5 pi over 6. Well, pi is the same thing as 6 pi over 6, so common denominator, multiply by 6 over 6. So 6 pi over 6 minus 5 pi over 6. That's the same thing as just pi over 6. Now, if you watched our earlier video with the 4 simple examples, you might not be surprised by this result. Okay, so the reference angle is pi over 6. That's what we just found out here. Okay. Now, what we mentioned in that earlier video is that for any angle times pi over 6, if you're talking about radians, the reference angle is going to be pi over 6. Okay, for any number, is what I meant, any number times pi over 6, the reference angle is pi over 6. Any number, any integer, I guess, times pi over 4, the reference angle is going to be pi over 4. So like 15 pi over 4, the reference angle is pi over 4. For 19 pi over 6, the reference angle is pi over 6. For 23 pi over 3, the reference angle is pi over 3. But remember, that only works for stuff like over 6, over 4, over 3. For other types of angles, which we'll do in a later example, the next example actually in the next video, it's not always going to work like that, okay? But anyway, for example 6, the answer is pi over 6. So let's talk about why we had to get the coterminal angle. Okay, so remember what we did when we first talked about reference angles a few videos ago, we said, okay, if you're in quadrant 2, just do pi minus the angle, okay? Now, 17 pi over 6 is in quadrant 2, but it's not between 0 and 2 pi, so that was the other restriction we had in that video earlier. Okay, you had to be between 0 and 2 pi, and if you're in quadrant 2, then do pi minus that angle, okay? Well, let's draw this here. So we'll come off to the side over here. Okay, so x-axis, y-axis. So let's draw 17 pi over 6. Well, 17 pi over 6 is just 5 pi over 6 plus 2 pi, right? So if you take 5 pi over 6 and add 2 pi, so 5 pi over 6 plus 2 pi, which is the same thing as 12 pi over 6, because if you multiply by 6 over 6, right? So that's just going to be 17 pi over 6, okay? So just add 2 pi to get to 17 pi over 6. So since 5 pi over 6 is over here, what we have to do is go around one full revolution, and then around once more like that to here. So that's 17 pi over 6, okay? And it is coterminal with 5 pi over 6. So these really, they do have the same terminal side, right? But we can't apply this logic to this angle because this angle is not between 0 and 2 pi. Okay, what happens if we try to do that? Okay, then we'll do pi minus 17 pi over 6, okay? Pi is the same thing as 6 pi over 6, then what we end up with is negative 11 pi over 6, and that's just all kinds of wrong, right? So we want to be very careful with that. So before we can apply this kind of logic, we want to make sure that the angle we're dealing with is between 0 and 2 pi, okay? And in this example, the angle that we started with is not between 0 and 2 pi, so what we had to do first was find a coterminal angle, or find the coterminal angle between 0 and 2 pi. Okay, find the angle between 0 and 2 pi that's coterminal with your given angle. So remember, that's what we want to do first, and the reason is coterminal angles have equal reference angles because reference angles are defined in terms of the terminal side, and coterminal angles by definition have the same terminal side, therefore they have to have the same reference angles, okay? So now we found the coterminal angle with this angle between 0 and 2 pi, and we do want to say the coterminal angle because if you have a given angle here, it's only going to have one coterminal angle between 0 and 2 pi. So find it, which means add or subtract 2 pi or 360 degrees as often as you need to until you get to that coterminal angle. Then once you have that coterminal angle, apply this logic here. Okay, so since we're in quadrant 2, we do pi minus the angle here. And that'll give us this stuff left over, which is what we want, and that in this case turned out to be pi over 6. Okay? So that's example 6 with reference angles, and it was more complicated because we were larger than 2 pi now. Okay? And if we had an angle less than 0, it'd be exactly the same thing, but we would add 2 pi once or twice or as often as we needed to until we got to where we needed to be. Okay? So again, that's example 6 with reference angles, and again, the answer was pi over 6.